started.
Hi, we're here at Fort Greely, Alaska at the Mechanical Electrical Building number 4, and it is March 18th, 2021. My name's Brian Rahm. I am the representative for XL Fire Systems. We are the company that installed the fire protection system here in the building. And this fire protection system consists of 2 different systems. Your pre-action systems. One is a single interlock, one is a double interlock. One of them has a higher level of protection offered for covering the electrical area, and single interlock is for the mechanical area. These systems are fed off of the underground that comes in out of the utilidor, runs in through this manifold and into this area here. We've got the control valves that are right down below the pre-action valves, riser 1, riser 2, and all of these are labeled on the emergency flow chart, which depicts where everything is. So primarily what this training is for is if there is an emergency that is not a fire, if there's an emergency that has evolved through a mechanical injury or possibly a freeze up in some fashion, where a pipe is split or someone has hit a sprinkler head, and you have to have the ability to shut the system off readily to mitigate damages, then you're going to want to know how to do that, and you want to know how to drain the system also. So in the event of something that isn't a fire, and this is for people that are non-fire personnel, then they may be people that are here in the facility and they need to have knowledge of how to do this also. We tell them what you do is you come up to these valves that are control valves, and if you are unaware of which system has gone off, if you have the wherewithal, you can refer to the system map here, or if you don't want to do that, you simply shut off both of these valves. These valves are indicator valves. They're indicator valves in that they indicate whether they're open or closed. And the way these particular valves do that is they have a stem that comes out, and this is called an outside standing yoke, OS&Y. And when the stem is out, it means that it's open, and if the stem is not out, it means it's closed. And in this case, you can see that these are out, and they're in the open position. And so if you needed to shut these off, there's arrows that show open. You would go in the opposite direction. You would close the valve, and the next thing that you would do is, in order to drop the pressure off of the system, you would open these main drains. They all have signs on them. These main drains are normally closed, and you would open both of the drains. That's really all you need to know at this point in time in order to shut the system down and drain it, simply to mitigate damages. Okay? Now, the other workings of this include, there's a nitrogen system that comes in and feeds air into this, supervisory air that allows the detection systems to determine whether to discharge during a loss of air. There are corrosion detectors up here. There are smart vents. These items will be talked about by the representative from Engineered Corrosion Solutions, and he will do that today also. We've got the fire department connection is right here, and it runs out through this check valve. It's directly outside, and this is an important factor for the fire department. If they come in during an actual fire, they're going to pull up to the fire department connection on the outside. They're going to hook their pumper truck up to it, and in turn, they're going to feed their pumper truck with the fire hydrant available, and they're going to pump water through the system and back up to augment the pressure on the system during the event of a fire. And this fire department connection has usually right above it in a proximity of approximately 10 feet, they're going to have a bell, and there's going to be a bell that's an audible on the outside of the building, and it serves two functions. The bell serves the function of, it sends out an audible signal that tells the public that there's an event going on and that someone should call 911. There's an accompanying sign on the bell that also says the same thing. The other thing it does is it has a distinctive sound to it, and because of its proximity to the fire department connection, in case it's a dark and windy and foggy night, which never happens here in Delta, Alaska, but if it did, and you couldn't find the bell visually, or the fire department connection visually, you might be able to hear that bell audibly. And that would at least give you a good indication of where it is, or at least what side of the building it's on. So that's the function that the bell serves. If there is a fire and the fire has been put out by the sprinkler system and everything has been shut down, the next thing is to try and get the system back up into running order as quickly as possible. That's important in that you maintain the integrity of your system at all times. So in order to do that, you're going to have a spare sprinkler head, and the sprinkler heads are kept in the sprinkler head box near this gentleman, and you have a representative sample of heads in the box with a legend that shows you what heads are available and what type, what temperature, and they're here, and they also are accompanied with wrenches, and the wrenches are for that particular head, so that once you identify what head has been activated, you can readily go in there, you can pull the old head out, you can put the new one in, you tighten it up, you follow the directions that are posted here on how to set the system back up, or you call us, or you call the maintenance people, and they set it up. But in any event, those are the procedures that you use in order to get the system back in. Obviously, if there's mechanical damage, if there's a pipe broken or something of that nature, you're going to call somebody that can do that. So, in summary, emergency shut-off procedures: shut off appropriate valves, open appropriate drains. Call whoever needs to be called, they'll let them know what is going on. In no event should anybody who is not the fire department do anything if there is an actual fire other than follow the protocols put forth by the base, usually exiting the building. Don't mess with the sprinkler system. Are there any questions?
Very good, thank you.
Okay. Now I'm going to hand this over to Steve Brown. Steve Brown represents Engineered Corrosion Solutions. They're the people that supply the nitrogen system that fills this system during the time that it sits in operation. And there's some steps involved in setting up the system. He's going to point out, as I did, no one's expected to get the whole thing at one time as far as how to do it, but he's going to give you the basics of how to run through the system, what to look for, what some of these devices are. And so anyway, I'm going to hand this over to Steve Brown. Mr. Brown?
Yeah, I'm going to start over here. Thanks, Brian. Once again, I'm Steve Brown with Engineered Corrosion Solutions. This is our P-Gen 3 wall hanging nitrogen generator. And we use the term generator, but it's basically a filter. We're not generating nitrogen, we're filtering the oxygen out of the air that we're breathing that's coming from the compressor. It's going through this coil, and it's going through this series of filters to take out any water or other particulates. And it comes down this hose through this membrane. We've got a high pressure here, we've got a back pressure here, and so we're kind of compressing the air through this filter in here, and it's forcing the oxygen and other particulates out of this port right here. So what we've got out here is a minimum of 98% nitrogen, and that's what we're using for supervisory pressure in the fire sprinkler system. Instead of compressed air consists of oxygen, 21% oxygen, and that's what's causing these dry systems to corrode, because even though it's called the dry system, After a trip and you drain it, you'll never get all the water out. There's groove couplings, there's always water traps and stuff. So that moisture, along with oxygen and steel, it's like a fire triangle, right? You got, but with instead of heat, fuel, and oxygen, you've got oxygen, steel, and water, your electrolyte. So what it's doing is that oxygen is corroding the pipe, and then once a leak occurs in the system somewhere, that causes the compressor to run even more, and it's forcing more oxygen into the system, which is causing more leaks. And so most people in the back of the day, they just go and get a bigger compressor to keep up with the leaks, which would keep feeding more air into the system and cause more leaks. So all we're doing is we're displacing the oxygen in the system with nitrogen. Minimum 98%. The science has shown that 98%, actually even 97%. We're still 10 times better than the 21% that is in the air we breathe. So that's all we're doing, is we're maintaining the system pressure with nitrogen instead of compressed air. Okay, so like I said, the air comes through the filter, goes out to the system here. This is a bypass mode here. So when there's a sticker here with the handle down, it's in bypass mode. And what we're doing is we're coming from the compressor and filling the system with compressed air. Okay, I'll turn this on. Oh, it is on. I need that here. Let me get some air pressure going here. This got an 8-second delay. There. That's what I want to do. I wanted to activate that. If that light is flashing, that tells you it's in bypass mode and it's putting oxygen into the system. We don't want that after the initial startup. So what we'll do, this compressor is sized to fill both of those systems, the largest single system, in 30 minutes or less. And those are real small systems, so it's going to take a couple of minutes to fill, is all. So we'll fill them with oxygen, with compressed air to start, and then we'll start a 14-day purge. So the nitrogen's going to come out here. As far as the fire guys, while I'm at the cabinet, the fire guys, you guys want to know how to change filters or anything like that in here? I've explained it to the maintenance guys, but okay.
We leave it to these guys.
Okay, perfect. So the nitrogen is going to go down here to your dry pipe valves or pre-action valves. And what we're going to do is we're going to vent the system out of these vents. We've got automatic air vents here. Power, these should power beyond. Oh, this one doesn't have power. Oh, there it goes. Okay. Let me close those. You hear that? That just opened the solenoid. So right now that vent is well, if this was open, these need to remain open when it's in service. And now it's bleeding air out of this system here, out of that vent. What we're doing is we're venting down the system pressure. So right now we've got these set at 20. So I've got that compressor set to kick on at 17 PSI. When this system bleeds down through that vent, and it's a real small orifice, so it's a slow bleed and a fast fill. So we don't want to trip systems, especially with accelerators and things. But when it bleeds down to 17 PSI, the compressor will kick on and fill it back up for 14 days. This vent has a timer in it. It'll close automatically after 14 days. After 14 days, and actually these zones are so small, it's probably only going to take about 6 to 9 days to get to 98%. But those will close automatically after 14. And so what we're doing is we're bleeding the air from the system down out this vent, and then we're filling it with nitrogen. And every time it does that, it'll do that 3 to 4 times a day for 14 days. And every time it does that, the nitrogen purity, the oxygen purity gets lower, and the nitrogen purity gets higher. And after 14 days, we're at 98%. That shuts off. You can check the nitrogen purity out of this port right here. I won't go into that. I'll get into it with the fire guys. I won't. And that's it. So then after it's done purging, it just sits in supervisory mode. It stays in nitrogen mode. And anytime the system naturally bleeds down, once it gets to 17 PSI, it'll fill it back up. That's how simple it is. Oh. Well, the corrosion monitoring probes up here. So this pressure switch, the green box right here on the end with the button to push there, that has a machined probe, and there's the wall, the pipe wall, it's kind of a piece of pipe tubing that's been machined down to a really thin wall. And so if any corrosion is happening in that system, that will corrode first. So if you push that button to test and it turns green, you're good. If it doesn't turn green, then it's been compromised. There's another way you can wire those to the alarm panel and you'll get a supervisory. Trucks won't roll, you just get a supervisory saying, hey, there's something going on with this. And then what we do if it does corrode, there's coupons, steel coupons inside that tube, the monitoring station, and we'll have them send those back to us for analysis. And it'll tell us what's going on inside the system. For years, I don't know if you guys have heard the term MIC, microbiologically influenced corrosion. Okay, well, I'll spare you for you guys, I'll spare you the science. I've got some stuff for you guys though. So that's really it. It's just replacing the compressor. We're replacing the compressed air with oxygen with 98% nitrogen, stopping any corrosion. Any questions?
If we're isolating the system post actual activation or post pipe break, is there anything we have to do on that panel to secure electricity, or is it just going to keep running without a sprinkler head trying to?
Yeah, it will run. The compressor will run as long as the air maintenance device
It's open.
that device there is open, which when there's pressure loss downstream, that's going to open, and that's going to call for air from the compressor. So yes, you could just there's a power switch on the outside of the cabinet, it's lit green, you can just kill the power until you're ready to fill it back up. And then that'll be one of these guys.
So if this system goes back into service the way it is now with one valve open and the other closed, what's going to happen?
Right now, that one will get nitrogen, this one won't.
Okay.
So when we're done today, we're going to leave both of those purging, and they'll be filling with nitrogen. These systems are so small, I probably couldn't fill them with nitrogen now, and not even have to do the 14-day purge. It just takes a little longer to fill, but
Once the purge process is over, is that when you open up the valve going into the corrosion detector?
yes.
Okay.
And that's smart to have those closed right now, because with all the testing and stuff that you guys have been doing, water getting in there, they'd be corroding right now. We've seen those corrosion detectors get installed and people didn't isolate them, and actually we've had some within 3 months. That's how fast the corrosion process can happen. Within a few months, they call us and say, well, these pressure switches are bad on the thing. So we say, well, send us the unit back. We look and know they actually corroded through. So it's a good thing you've got those closed until we're actually putting the system in service, because they could corrode. Especially, how long has this been in the process of building? It's been a while, right?
Yeah, pretty much.
Okay. So yeah, so that's good that you've got them isolated. So that's unless there's more questions, that's it for you guys, and then I'll finish the maintenance stuff with those guys after I do a couple things over here. You good?
Thanks,
guys.
gentlemen.
Appreciate you.
And that can